is Robin. So we will be solving this question number 22 from GATE 2014. So as you can see, this is the question which is partially from quantum mechanics and would need the concepts of quantum mechanics, and also from the solid state physics, or you can say condensed matter physics. Now this is a very basic question. So as you must have derived the energy dispersion and the eigenmodes for the case of one-dimensional monoatomic lattice by just simple idea of the vibration, degree of freedoms, and involving the displacement, you must have seen such sort of relationship for the phonons. But this is the electronic structure, and you can just clearly see in solids what really happens. It's not basically a free particle. Okay, so the energy dispersion is not p square by 2m in solids. This is in free particle. Okay, so now you can see it's approximately free particle, as you can see close to the k equal to 0, but then you can see at the Brillouin zone edges, which describe basically the periodicity of the solid, you can see that this energy is going constant at the edges minus pi by a and pi by a, corresponding to this one-dimensional lattice of the lattice constant a. Now you just have to select the correct option for the group velocity. Now you are given basically E as a function of k. Now you are asked to define the correct relation of V as function of k. Now that is very simple. Basically the group velocity would be nothing but the derivative of this ek with dk. Right, so you should know how the derivative is behaving. Now you can see at this point the derivative is 0. At this point the derivative is 0. At this point also derivative is 0. So the option C is never possible, and option D also not possible. At all the 3 points, which are minus pi by a, 0, pi by a, your velocity has to be 0. So C and D are out of this option. Now you have to see how the derivative is changing. So you can see first the derivative starts to decrease, right? So basically it's the negative side which has to be in the first. So it has to be like this, and at some point it will reach the maximum amplitude in the negative side. Then it would again start increasing and go back to 0. Then it would become positive, and after some time it would start decreasing in the positive side, and it would again goes to 0 at pi by a. So clearly the B option is the correct one. So it's clear, it's just required you to know the definition of group velocity, which is derivative of the energy with k, and you should just, from the dispersion, you can clearly guess what would be the correct option corresponding to the velocity as a function of k. Thank you.